Good day everyone. So this is the continuation or the part 2 of the topic masses of variable density. So let's continue. So now we are now in the center of mass. The center of mass or the quantity of x and y mean of a planar plate that is distributed over a region R with density x, and the quantity of x and y is determined by the equations. So mx is equal to my and my mean is equal to mx, where my is equal to double integral r density times the quantity of x and y times x dA, and mx is equal to double integral r times density times the quantity of x and y times y dA. An analogous result holds for the center of mass of a three-dimensional body. The reasoning is similar to that for centroids in chapter 55. The center of mass, the moments of inertia of a planar mass with respect to the x-axis and y-axis are Rix is equal to double integral r times density times the quantity of x and y squared dA, and y is equal to double integral density times the quantity of x and y x squared dA. So similar formulas with triple integrals hold for three-dimensional bodies. For example, Iy is equal to triple integral r density times xyz times the quantity of y squared plus z squared times dA. Example, find the center of mass of a plate in the form of the segments cut from the parabola y squared is equal to 8x by its latus rectum is equal to x is equal to 2. If the density varies as the distance from the latus rectum, so here is the solution. M is equal to double integral r times density times x and y dA is equal to integral 0 to 4 and integral y squared over a to 2 times k times the quantity of 2 minus x times dx dy. So integral, you just copy the equals of the formula, which is integral y squared over a to 2 times k times 2 minus x times dx. So let k is equal to integral y squared over a to 2 to x minus x squared over 2 dx. So k is equal to 2x. So here the integral symbols is eliminated, so 2x minus x squared over 2, then y squared over a to 2. So k, the value of x, which is 2, you just substitute. So k times 2 to the times the quantity of 2 minus the quantity of 2 squared over 2 minus 2 times the quantity of y squared over 8 minus y squared over 8 over 2 to the power of 2. So k times 4, because 2 times 2 is equal to 4, minus 2 minus 2, because 2 times y squared is 2y squared over 8 minus 2 times y squared to the power of 2 is y to the power of 4 over 64. 8 times 8 is 64, so over 8 over 2 rather. Next, k times 2 minus 1/4, because 2 divide 8 is 1/4 y squared. You just copy y squared plus y to the power of 4, 64 over 2 is equal to 1 over 128 y to the power of 4. So integral 0 to 4 k times the quantity of 2 minus 1/4 y squared plus 1 over 128 y to the power of 4 dy. So the value of dx is, so our value of our dx is integral 0 to 4k times the quantity of 2 minus 1/4 y squared plus 1 over 128 y to the power of 4 dy. So continue using the formula. So k times integral 0 to 4 to y minus 1/4 integral 0 to 4 y to the power of 3 over 3 plus 1 over 128 integral 0 to 4 y over 5 over 5 dy. So k integral 0 to 4 to y minus y 3 over 4 times 3 is 12. So you just copy 12 plus 128 times 5 is 640. So y to the 5th over 640 dy. So k 2y minus y3 over 12 plus y5 over 640 from 0 to 4. So k, the value of y, which is 4, you just substitute. So 2 times the quantity of 4 minus 4 squared over 12 plus 4 to the 5th over 640. So k, 2 times 4 is 8 minus 4 times 4, 16. 16 times 4, 64 over 12 plus 4 to the 5th is 1024 over 640. So k, the quantity of 8 over 3 plus 8 over 5. So k, 40 plus 24 over 15. Using the multiplicative method. So 8 times 5, 40. 3 times 8, 24 over 15. So 3 times 5 is equal to 15. So 40 plus 24, 64 over 15, or the lowest term is, so there is no lowest term in 64 over 15, so you just copy 64 over 15k. So the answer of m is equal to double integral r density times x and y dA is equal to 64 over 15k. So that's all. Thank you.